Hello students, welcome to the video lecture series on electrical installation, maintenance and testing. We have started with the unit number 1, distribution system, and we have discussed the types of distribution system. The types are the primary and secondary distribution. In the today's class we will discuss the definitions of the second classification, that is called as a depending on the scheme of connection. So uh, if it is not in your syllabus, so then also we are interested to take this scheme of connection. So they have mentioned clearly that the type of primary and secondary distribution systems, they have not mentioned this scheme of connection, but for the knowledge purpose we will take this point. All the distribution of the electrical energy is done by constant voltage system. So this point you have to keep in mind. So whenever we are interested to make the distribution system depending on the connection, then we have to use the constant voltage as a parameter. So the first subtype is the radial system. So let's say this is a substation. From this substation there is a feeder. On this feeder there is a distributor is available, and this is our service mains. Yes. So this we have discussed already. Let's say this is the diagram called as single line diagram. Single line means on a single line we are representing our system. So that is called as single line diagram. So this is a radial system for DC distribution. So OC supplies the distributor. So and AB at a point A. So this is a distributor, and this is called as OC. Yes, so this is our feeder. The second single line diagram is for AC distribution. So simply this is a substation. Same way this is a OC feeder, and in this on this feeder we are using a distribution transformer. So now tell me, this is a primary distribution or secondary distribution? So obviously it is a conversion of 11 kilovolt to 400 volt. So this is the secondary distribution, and at this secondary 400 volt we are applying the load, or we are getting the load. So this is called as a 400 volt load. So this is the single line diagram of radial system for AC distribution. Now separate feeders radiate. So the radiate means pasarane or to spread in all direction. So we can say that this is the one direction, this is the second direction, and this is the third direction. So from a substation we are spreading the feeders in all directions, in all possible directions. So that is called as a radial. So separate feeders radiate from single substation and feed distributors at one end only. So from single substation and feed the distributor at one end only. So this is the distributor at one end only. So that is called as a radial. Employed only when power is generated at low voltage and substation is located at center of load. It is the simplest distribution system and has the lowest initial cost. So this is you can consider as a advantage. Now we know that as the system is there, or as the types are there, so every system has its own advantage and disadvantage. Now by the point of drawbacks or the disadvantages for the radial system, the consumer are dependent on single feeder and a single distributor. So this is called as a drawback. So if there is any fault on this particular feeder, so whole connection or the line will get shut down. So this is a drawback. So any fault on the feeder or distributor cut off the supply to the consumer. So this is a simple drawback, and which is a major drawback of the radial system. When the load on the distributor changes, there will be the voltage fluctuation. So this is not permissible. Voltage fluctuation will not be permissible at all. So this is a drawback. Now we are interested for a second subtype, that is called as a ring main system. Sorry for the clarity of the picture. I hope you can see this picture. Let me explain this picture first. So this is the primary ring, and the name of the primary ring is LNPF. And at the point of MOQS, there are, you can say, distributors. So we are forming the ring. So this is the ring structure, and on that particular ring, at the midpoint of that, you can say, the feeder, we are tapping the distributor. So here you can see we are using a transformer. Obviously this is the AC rings main system. So let's say at O point we are using a distribution transformer. Now tell me the voltage rating. It is same as previous, 11 kilovolt by 400 volt. So, and we are getting the tappings here. So same way at Q point also, at S point also there is a one substation, and at M point also we are tapping the voltage with the help of these service mains. So from the substation there is a formation of loop. So this is the substation, and from the substation you can form one loop. The loop starts from the substation bus bars, makes the loop through area to be served, and returns to the substation. So from this starting you have to follow the ring. Yes. From figure, substation supplies to the closed feeder LMNOPQRS. So this is the LMNOPQRS. So this is the ring. The distributors are tapped from the different point MOQ of a feeder through the distribution transformer. Now the previous disadvantages are covered here. So the less voltage fluctuation at consumer terminal. So this is a perfect, or you can say, we are following this system. The system is a very reliable, as each distributor is fed by the two feeder. Let's say for point M is supplied by feeder, the SLM and SRQPONM. So you can say that if there is a fault on, you can say, for the particular line, so we can feed the power with the help of SLM, or we can feed the power from SRQPON. So this is the another way. In the event of fault in any selection of the feeder, continuity of the supply is maintained. So this, the previous drawback is covered here. Now we are interested for the third sub classification, that is called as a interconnected system. As the name implies, we have to interconnect all the substations throughout this the use of all the feeders. So that is called as interconnected. Let me explain this diagram. So this is the S1 substation, this is the S2 substation, and we are interested to connect these two substations with the help of this interconnection medium or interconnection system. So no doubt we are following, or we are using the ring structure connection, and you can say that if we are interested to connect the S1 and S2, then we can use this interconnected system. So we are forming the substation, we are forming the ring like COBRAQDP, and at this point, O point, we are tapping the voltage. So at this R point we are tapping the voltage, at this Q point we are tapping the voltage, and at this P point we are tapping the voltage. When the feeder ring is energized by two or more than two generating stations or substation, it is called as an interconnected system. So this is also the advantages. The figure shows the SLD or single line diagram of the interconnected system, where ABCD supplied by two substation S1 and S2 at point D and C respectively. So let's say this ABCD is supplied with the help of substation S1 and S2 at point D and C. So that we have written. Now the advantages are, it increases the service reliability. So even if the let's say the fault at particular point, so or you can say if the S1 is doing some maintenance, or if there is fault in S1, so from the help of S2 we can provide the power to this point. or let's say here there is a fault, or on the S2 there is a maintenance work is going to carry out. So with the help of S1 we can flow the power entire with the help of this path to this point. So that is a, you can maintain the continuity of the supply. Any area fed from one generating station during the peak load hours can be fed from other generating station. This increases the efficiency of the system. So I hope you understood the concept of radial, ring and interconnected system. So these two systems are depend on the scheme of connection. In the next class we will discuss the design considerations to make the system reliable. Thank you. God bless you all.